Okay, students, here I am back with the second video looking at the graph of tan x again and some specific examples. So I just wanted to look at sort of a prettier version. This one does not have the asymptotes drawn in, so let's go draw them in. Remember, those are occurring at all of the pi over 2's. Okay. All of our zeros are occurring at increments of pi, 2 pi, so then negative pi over here would be that one. So we've got a period, that's pi. Amplitude doesn't really apply here. Instead, our a value, when we think of our original graph, so we'll have y tan x. So we've got amplitude doesn't apply here. Our a value is 1, but that's vertical stretch. So if a was bigger than 1, then this curve here would be steeper. Yeah, it would be steeper this way and sort of steeper that way. Our b value still talks about the period. So in this case, pi divided by b is going to give us the period. C is going to be same thing, phase shift, and the d value is going to change where the zeros are at because everything would shift up by the d. So if we had a d value, all of these would move up, and so our zero would happen differently. So let's look at what we've got here. So in this case, we've got a normal stretch factor, and we have a shift to the left of pi over 2. All right, so that means that all of our zeros have moved left pi over 2. Oh, goodness, sorry. So instead of having the zeros happen on increments of pi, our zeros are going to happen on increments of pi over 2, and our asymptotes will happen on increments of pi. So I'm just going to count, let's say, by 4s. So 1, 2, 3, 4, and we'll call this pi over 2. So instead of being an asymptote, that's going to be a 0. Let me think, am I moving this to the correct direction? So we should have gone to the left pi over 2. Let's correct that. So let's make that our axis, and we'll call this one negative pi over 2. Okay, so if we think about the original graph, so my original graph goes through 0, the point 0, and now we're shifting everything to the left pi over 2. So all of this is going to come left pi over 2. So now that's going to be our 0. We're going to have an asymptote on the axis, and then we'll have another 4. 1, 2, 3, 4. That's going to be a new y-intercept. 1, 2, 3, 4 is a new asymptote. 1, 2, 3, 4 is a new intercept. 1, 2, 3, 4, new asymptote. And of course I can label these asymptotes. We've shifted everything by pi over 2. So this is going to be pi, this is going to be 2 pi. And a tan graph, if I want to, at pi over 4, that's when it's equal to 1. So pi over 4 are my 1s. Pi over 4 in this case would be negative 1. I move over pi over 4. That puts me up at positive 1. Okay. Negative, up. And then there's our general graph. So we've moved tangent over by pi over 2 to the left. Okay, this one tells me that the period now is going to be pi divided by 1/2. So that's going to be 2 pi. But if you get stuck on tan, it's okay to just think about it. So remember that tan is y divided by x, or sine divided by cosine. If I think about when sine is 0, that's at 90 degrees. Half of 90 would be 45, so that doesn't work anymore. But half of pi is going to be pi over 2. That'll make 0 for sine. No, sorry, that would make 1 for sine and 0 for cosine. How about we write down what I'm talking about so that you can see it and think it at the same time. All right, so if x is 0, half of 0 is 0. I know that that means that my tan value is sine 0 over cos 0. That is 0 over 1, so it's 0. Let's do easy ones for tan. So if x is pi over 2, this is going to be sine of pi over 4, cos of pi over 4. Those are, of course, equal to each other, so that's 1. And at pi, that'll be sine of pi over 2 over cos of pi over 2, which is 1 over 0, so it's undefined. Okay, so I'm going to go ahead and plug those points in, what we just talked about. So I've got the point 0, and then over at pi over 2, if we call 2 spots pi over 2, that's going to give me my 1. And then, so here's pi over 2. And that would be pi, and that's where we're undefined. So I'm going to put in an asymptote. And now this is just the top part of my graph. So it would continue down this way. That means that I have a cycle of here is pi, and that's half a period, which makes sense because I've said that my period is 2 pi. So my next asymptote is going to be over you can't see me counting, but I was counting. And now I don't remember if I counted to there. All right, so there's my next asymptote. I will have over there is going to be my -1. That's going to be my 0. And up at my +1. And for tangent, that's enough points to really think about. So with tangent, the important parts are the asymptotes, getting the asymptotes in the right place, and getting the zeros labeled correctly. So this 0 over here is going to be 2 pi away from my original. Let's go ahead and label that. And then half a period away is going to be the asymptote. So that's 3 pi, and over here is pi. So make sure you've got your asymptotes labeled, your zeros labeled, and that's really enough for tangent. If we have a stretch factor of a, then we're also going to want to see how the 1 gets moved up or down, as the case may be. And we'll practice this more in class. I'll see you there.